accepted.
Right, thank you for joining me. Good morning. So this talk is really about the C4 model for visualizing software architecture, and it's a collection of the misconceptions, misuses, and mistakes I've seen in the past few years or so. Quick show of hands, although I can't see much. Who's using C4? That's a good chunk of you. Awesome. So this is kind of more advanced C4 content, but I'm going to do a quick introduction for those of you who might not be aware of it. So what is the C4 model? The C4 model is essentially, well, architecture diagrams are historically very bad. Across the industry, they're typically horrible. UML fixes a bunch of these problems, but nobody wants to use UML these days. Why? Here are all the reasons I've literally had told to my face. It's worth noting that many of these are actually fictional. The tooling sucks. You'll be seen as old and old-fashioned. It's not expected in Agile, etc., etc. I'm sure some of you have heard these as well. So the C4 model, which you can find at c4model.com, it's really a lightweight, structured way to create software architecture diagrams. And the concept that sits behind C4 is essentially this. If you don't want to use UML and you do want to use boxes and arrows, try to do so in a structured way, ideally with a self-describing notation. C4 is really two things, and you'll see this echoed through the next 50 minutes or so. The first of those things is a set of hierarchical abstractions. This is your software systems, containers, components, and code. So a software system is something that we as a team are building. It's something that we can see inside of. We can see the implementation details of, etc., etc. If you zoom into these things I'm calling software systems, I'm going to say they are made up of one or more containers. Nothing to do with Docker, unfortunate clash of naming. I got the name first. I know that's irrelevant. By container, I basically mean an application or a data store. So a React app, an Angular app, a Spring Boot app, etc. Or a data store, so an S3 bucket, a relational database schema, a folder on a file share, and so on. Zoom into these things I'm calling containers, specifically the applications. I'm going to say they are made up of components. By components, I mean grouping of related functionality, nice, clean, well-defined interface, hopefully, running inside a container. So, and this is important, and this will come up later as well. It's the container that's the individually, separately deployable thing in this set of abstractions. Zoom into a component, it's basically made up of code. So if you're building a Java component, that Java component is made up of enums, classes, interfaces. Same with the language. So that's the set of abstractions. And then we have a set of diagram types, and this is actually what C4 is named after. It's context, containers, components, and code. And those four levels of diagrams essentially map onto those four levels in the hierarchy. And the concept here is diagrams as maps. So I live in Jersey in the Channel Islands, which is this thing here. If you ask Google Maps for a picture of Jersey, it's going to give you that picture probably. And this is great if you want to know where the airport is and where the roads are and that sort of thing. But if you've not heard of Jersey before, it's too much detail too quickly. So how do you solve this problem and get more context? You pinch to zoom out. You could also zoom in and get down to Street View if you want to. And Street View is a nice one-to-one mapping with the real world when the photos were taken. And the C4 model is essentially the same thing. It's different levels of diagrams that allow you to tell different stories to different audiences, both technical and non-technical. So I'm going to briefly describe the top two levels of diagrams because it's kind of important for the rest of this talk. The top one's a system context diagram. And it basically says, here's the system you are building, and this is the world around it in terms of people and other software systems. So in order to draw that type of diagram, here's the set of questions that you essentially need to ask. What's the scope of the thing we're building? So what features sit inside our system boundary? What features sit outside our system boundary in systems around us? Who is using the system we are building? What types of things are they doing? And what are the system integration points? Answer those questions, and you can draft up a system context diagram. So the red box represents the system that this group were designing, in this case. They have correctly identified the features of that box, that system. They have correctly identified a couple of the different types of users in terms of roles here, and they've correctly identified some of these system integration points. So that's an example system context diagram. Now we can zoom into that red box and we can drop down to level 2. This is the container diagram. And it's a different set of questions. So what are the major technology building blocks in terms of applications and data stores? What are the responsibilities of those building blocks and how do they communicate? Answer those questions and you can draft up a container diagram. So now we zoomed into that big red box and we're now showing applications and data stores that sit inside our system boundary. In other words, as a team building this thing, that's what we're building. And that's it, in a nutshell. There's a website, c4model.com. All of this is explained on there. There's some FAQs, some example diagrams, some tips, etc., etc. So we're all good, right? No. So let's dive into some of these questions. This is cropping up quite a lot at the moment. I've only just heard of C4. I guess it's new. Nope. I'm not against using C4, even though I got the feeling it needs to become more mature. So it's kind of hard to exactly say when I came up with C4, but the actual ideas I can trace back to 2006, 2007, something like that. So this has actually been around for 15 plus years now, and it's really a formalization of the way that I used to draw architecture diagrams in that post-UML era of the kind of mid-2000s when I was needing to draw diagrams myself. People ask me, why have I reinvented UML? That's an awkward question. I don't think I have reinvented UML. I mean, people don't want to use UML for all the reasons I already showed you. And some people say, well, you've just created another thing. And you might have seen this cartoon kicking around the internet. There are 14 competing standards. We need another one. And people think that's what I've done with C4, and I hope it isn't. Because for me, C4 is essentially, it's 4 things, which is a bit weird. It's a set of hierarchical abstractions. That's what I explained before. It's software systems, containers, components, code. It's a set of hierarchical diagrams, context, containers, components, code. It's notation independent, and it's tooling independent. So UML gives you lots and lots more stuff. So for me, this isn't really reinventing UML. It's doing something different. If anything, it's about providing guidance to people who want to use UML. I keep seeing questions like this pop up. I've recently come across C4. Any insights, tips, or anecdotes would be appreciated. And then you'll get some people replying with stuff like this. Yeah, we tried it. We went down that path for a while. It's a giant waste of time. Thanks. You read on more text. It turns out they're basically talking about tooling here. So whichever tooling that they found that supported C4, it kind of drew them down a path, sucked them down a path, and it wasn't for them. I'm going to go back to that previous slide. The C4 model is tooling independent. You can quite easily do C4 on a piece of paper or a whiteboard, or there's a whole bunch of tooling out there that can help you. So just be careful when people associate C4 with some tooling. That's not the case. It's tooling agnostic. So C4 has the number 4 in the name because there are 4 levels of diagrams. Easy? Perfect. My advice when I teach C4 is that you should really only look at the top 2 levels. That's the system context and the container diagrams. These are quick to build. They're relatively stable unless you're building like a serverless functions as a service, microservices style architecture. Once you drop down to levels 3 and 4, the diagrams become more complex. They're more volatile. They're more impacted by small changes to your code base. So with this in mind, people say, well, why is it called C4? Why not just call it like C3 or C2 plus 2 or some other weird name that implies that you don't need to use all the levels? It's an interesting question. From my point of view, I like having the 4 well-defined levels because that bottom level anchors you in your actual code base. If you've seen some of my other talks on this topic, you'll know that George Fairbanks, in his book, Just Enough Software Architecture, has this concept called the model code gap. And it's where the top-down view of our architecture, in terms of modules, components, services, et cetera, doesn't necessarily match the bottom-up view of our code base in terms of packages and classes and modules and things like that. There's kind of a gap in between. Having, from my perspective anyway, having level 4 here gives you traceability up and down. and it anchors the whole thing. If you slice off level 4, you've just got these 3 arbitrary levels of abstraction kind of floating around a code base. So for me, it's about having that anchor. And yeah, I definitely don't recommend most teams use levels 3 and 4, but they're there for completeness for that anchoring. This is like a bonus question. Why doesn't my own tooling support level 4? So I have a whole bunch of tooling since I was last year. This is all now free and open source. You can find it on GitHub. But why doesn't my own tooling support drawing diagrams at level 4? It's relatively straightforward. Number 1, few teams use level 4. Number 2, level 4 represents code, which is all of your procedural languages, your OO languages, your functional languages, all of your database schemas. So in order to draw those diagrams, any tooling would need to support all of those things, which is a huge amount of things. So quite frankly, it's just a lot of work. And there are tools out there that have these diagrams already. And I think we should just reuse them. So UML is great for drawing OO code level diagrams. Entity relationship diagrams are great for modeling database schemas. These things exist, let's just use them. So from my tooling perspective, if you have a C4 component diagram, what you can do is you can add detail at level 4. You'll see there's a little magnifying glass there. If you double-click that in my tooling, you'll get taken to a UML diagram which was produced and generated by a different tool. So my tooling kind of allows you to slurp in other diagrams, other notations, which I think is a nice way to kind of solve this problem, because then you can just automate generation of those low-level diagrams. Notation type stuff. This is the thing that annoys me the most. I'll be completely honest with you. And the thing that people always say is the blue and gray notation of C4 is boring. I'm like, oh wow. The default 3 theme is an eyesore. Should we create our own themes? Yes. So imagine you're in my situation. You've come up with this way to draw diagrams. In order to show some examples, you need to draw some example diagrams. When I drew my example diagrams, I chose blue and gray boxes. Why? Because I liked blue and gray boxes. That's it. And that's fine, and I can explain my example diagrams with my nice blue and gray boxes, and I used different shades of blue, so like dark blue were like high-level abstractions, and as you got lighter blues, they were going lower into the hierarchy, and I just liked that. I thought it was nice. Unfortunately, people think that's the C4 notation, and I've seen this crop up in blog posts online. It's like, oh, I don't like the notation. C4 is notation independent in theory, but when you look at everybody's diagrams, they all end up using the blue and gray boxes. That's absolutely not the case. I've visited tons of organizations in tons of countries. I have some tooling, so I've also seen tons of diagrams through my own tooling, and they're not all blue and gray. I can absolutely guarantee you that the majority of people are not using blue and gray. What I found quite funny about this particular blog post is they propose a better or a different notation. And it says here, the new proposed notation uses a simpler color scheme. So basically, they were just going for one shade of blue, not multiple shades of blue. And I'm like, maybe. And then they say, and you can use red and green for like future changes. Yay. You could do that anyway, because C4 is notation independent. One of the reasons that this kind of hurts me most is because you have all these tools that are supporting C4, by default, they also render boxes as blue and gray. So C4 Plant UML does blue and gray boxes by default, as does the templates for draw.io, diagrams.net. And tons of the other tooling have picked up that blue and gray notation. So that is one of the reasons why I think people stumble upon blue and gray boxes at first. But as I said, it's notation dependent. You can use any shapes, any color you want to. So, fun fact, a little backstory for you. When you go to c4model.com now, you'll see this, and I have those same example diagrams. If you refresh the page a bunch of times, you might get green ones or red ones. Because I'm absolutely fed up of people telling me about that blue and gray boxes. So yeah, there's a bit of randomness in here now. I kind of get the same thing with relationships. This popped up on a LinkedIn discussion a couple of weeks ago. C4 is really limited because it only has one type of arrow. By default, many tools have a single type of arrow. It's either a solid line or a dashed line with just a simple arrow on the end. My take on this is if you want to impose semantics on top of this, you can do so through diagram notation. So if you want to show that a relationship is synchronous, maybe use a solid line, and if you want to show that a relationship is asynchronous, maybe use a dashed or dotted line. For me, that's where notation comes into play, and you create your own notation with your own semantics. If you want to now add coloring, and you want to say green is secure and red is insecure, so maybe like HTTPS and HTTP, that's fine. Make sure that's a part of your key of your legend. This also popped up on a LinkedIn discussion. C4 is unclear because you are forced to place a lot of text in every box. It's actually the opposite. So although C4 is notation independent, this is more of a Simon says you should think about adding text into your boxes. Because if you look at most architecture diagrams, they look like that. They're just a box with one or two sometimes very ambiguously named things inside them. If you see this diagram for the first time and I say, what do you think the file system does? The only logical answer you can give me is stores files, which is not particularly useful, I grant you. So I'm a fan of adding more text. So now we can talk about responsibilities or the types of data that's being stored in that data storage thing. And it gives us a nice at-a-glance view. You know, we know naming is hard, we get that. So this gives you a nice at-a-glance view. It removes some of the ambiguity around what these boxes might be doing. Because, of course, a single thing in software can do lots of different things, and that's the problem. If we draw like a zigzag on an electrical circuit diagram, it's a resistor and it does one thing. Our software boxes sometimes represent many things, especially where we've got those big balls of mud and all the functionality has been stuck in one box. So that's why you'll see many of my example diagrams are quite text-heavy, and indeed my structurized tooling kind of promotes a text-heavy approach, and some people don't like that. And they'll say, well, we find this too cluttered, so we started removing things like the metadata and the descriptive text. So what do I mean by the metadata? Again, although C4 is notation dependent, I have a set of recommendations, and one of those recommendations is, inside every box you have a little piece of text that says, this is a software system, or this is a container, so we know exactly what level of abstraction we're looking at. And you'll see that rendered like this. So it's very precise. And I like that precision. People say, well, just remove it, because once you come up with a good notation that everybody understands, when we see core bank DB, we know exactly what that thing is. I wish that were true. If this were true, we wouldn't be here having this discussion now, and this whole diagramming thing would not be an issue at all. So for me, removing the metadata and the descriptive text is really introducing problems that I'm trying to solve with things like C4 and my recommended notation. So I do absolutely encourage teams to add that descriptive text. Now, I do grant you that these diagrams do look cluttered. And I've seen teams and literally put entire essays inside boxes. Please don't do that. Please keep this like one sentence. And sometimes you might want different versions of your diagrams for different use cases. So maybe you want a version in your documentation with all of the detail, and then maybe you want a simpler version with bigger fonts that you wheel out for doing a PowerPoint presentation. That's fine. Maybe have multiple versions and find some tooling that allows you to turn on and turn off the different levels of information. For me, that's a really nice way to deal with this problem. Viewpoints. So the way we look at C4 model diagrams. This is quite common. The C4 model is not good at showing decisions. Absolutely correct, and I 100% agree with this. And do you know what? It's not supposed to. For me, an architecture diagram, irrespective of whether you're using C4 or UML or Archimate or some other formal notation, for me, an architecture diagram is about showing you the outcome, the end point of your decision-making process. It's not about recording the decisions on the diagrams themselves. And that raises the question, well, where do we record the decisions? And the answer is in a set of decision records. So if you're not using ADRs, definitely go have a look at ADRs. Michael Nygaard's got a bunch of stuff, and there's other people who talk about this online as well. For me, this is a much better way to record decisions with context and consequences and status, and you can link these things together, source code control them, etc., etc. So have a set of these, and have a set of diagrams that essentially show you the end point of all of those things wrapped up together. People tell me that C4 omits the deployment story. C4 is named after the 4 levels of diagram I showed you at the start. And it's true that those 4 levels of diagrams are the static structure diagrams. So from that perspective, the static structure diagrams omit the deployment story. However, if you go to c4model.com, there's a little banner at the top, and here are the 4 diagrams. There are also some other diagrams, some kind of supplementary diagrams defined on the website as well, and one of those is a deployment diagram. So I keep my deployment information off of the C4 model container diagrams for two very simple reasons. Number one, it's very cluttering. If you start adding deployment information to a container diagram, it becomes very cluttered very quickly. What do I mean by deployment information? Servers, IP addresses, VPNs, VPCs, all that stuff. Number two, imagine we're building a piece of software. I might want multiple deployment diagrams, one per environment. So here we have an example deployment diagram. This is the one on the site. And it shows you what the development environment might look like. So when I'm doing development, I have my own developer laptop running a web browser. That's where my single-page app code is running. I have a couple of Docker containers running my other containers, my other C4 containers. When it comes to the live production environment for this same code base, it's not going to look like a bunch of stuff on a developer laptop inside Docker. This might be now sprayed across multiple machines and VPCs and VPNs and that sort of thing. So leaving off the deployment information from a container diagram allows me to have flexibility to create multiple deployment diagrams, one per environment. That's the thing in a nutshell. Cloud architecture diagrams, sure. There's absolutely nothing stopping you doing cloud architecture diagrams in this same style with the AWS, Azure, icon set, etc., etc. And all of those things are also linked to on the C4 model website. We don't need C4 because we do DDD or event modeling instead. Where has this come from? This has popped up in the past couple of years, and I don't know where it's come from, but I suspect it's from cartoons like that. Has anybody seen this? A few people. Yeah. This quote actually popped up on Twitter last week. I personally prefer event modeling over C4. C4 has the major downside that it does not reflect the concept of time very well, which I completely disagree with. So let me change the words event modeling and C4 to 2 other words. I personally prefer knives over forks. A fork has the major downside that it does not reflect the concept of cutting very well. A knife and a fork are 2 things and they're complementary. They have different primary purposes. For me, it's the same with event modeling and DDD and C4. You can use all of these things in collaboration. They're very complementary. They're not designed to replace one another. So let's address the timing thing first. Again, if you go to c4model.com, you'll see there's a dynamic diagram that's defined on the top. And a dynamic diagram is essentially a UML collaboration style diagram that allows you to see the interactions of C4 concepts across time using numbered ordered arrows. So that's defined very clearly on the website. You could also use something like a UML sequence diagram, of course. So back to event modeling very, very quickly. What is event modeling? Event modeling is a way to design a blueprint for an information system of any size or scale. It is done in a way that allows the clearest communication of the system's workings to the largest possible cross-section of roles in an organization. So that's what they summarize event modeling as, and if you go to the Twitter page, it kind of says the same thing in fewer words. It's a way of describing information systems for all roles in an organization. This is a very bold, ambitious goal. And that's an example event modeling diagram. I have no doubt that this is super useful for the people who created it, and it shows you the processes and events and that sort of thing. If you give this to an infrastructure person and say, can you support this? They'll be like, what am I supporting? So this shows you an angle of a system. It's not showing you everything. And for me, that's where C4 comes into play. This is great for one perspective, but C4 comes in and shows you the ultimate software things that we end up building and delivering and installing on servers, be it on-premises or the cloud. So again, it's a complementary thing. In terms of DDD versus C4, if you want more information about how to do that, go to Nick Tune's blog. He wrote an article about this years ago, about how to do kind of DDD-style architecture diagrams. Because, of course, they're kind of almost but not quite orthogonal concerns. C4 showing technology and functionality, and DDD has a different view of that same stuff. So imagine you're building a microservices architecture. Your C4 container diagram might show you there's microservices, but then you might want to superimpose a kind of DDD bounded context or set of aggregates on top of that diagram to maybe show how that multiple services fill a single bounded context, for example. So again, almost but not quite orthogonal concerns. Naming is hard. Abstractions are hard. One of the questions I get a lot is, why don't we just show all the same, well, let me start again. Why don't we show multiple levels of detail on one diagram? So rather than drawing 2 or 3 diagrams, why don't we just collapse those 2 or 3 levels of detail and show one simpler diagram? And the answer is because you don't get a simpler diagram. You get a diagram that's actually quite cluttered. So with small systems, it's very tempting to merge the context diagram with the container diagram, but I would recommend not doing that because it will get cluttered at some point. Naming is hard. People don't like my name container. And I get that, and that there is an unfortunate clash of naming with Docker, of course. And I get people say, well, we're using C4, but we've renamed the abstractions to something like software system component, subcomponent, and code. I'm all for teams renaming C4 to suit their context and the language that they use. I would just be super cautious about promoting the component name up to what is referred to as the C4 container, because I think that adds quite a lot of confusion. On this whole naming thing and abstractions in general, I saw this online earlier in the year. A database is a database. Debating whether it's also a container or a component just isn't worthwhile. Where did that come from? It's a snippet from a much bigger blog post, which you can find here. And this is the context. The problem is that systems today have many types of things, servers, databases, APIs, etc. And trying to force them into C4s for abstractions is not worthwhile, is essentially what this post was all about. I disagree with this because what's a database? A database is a database. What does that actually mean? What is a database? Are we referring to a database server, a schema, a collection of things, a product? That one word is often misused quite a lot. You often hear teams say, microservices should not share a database. Does that mean that they shouldn't store data in the same database server? No, probably not. I think it means that microservices should not have shared database schemas. I think that's the intent here. But we're not being very precise with the terminology and the words that we're using. And for me, that's the root problem in much of the architecture diagramming stuff. We're not precise. And I encourage teams to be more precise with our terminology. And this is exactly what the system versus container versus component debate kind of forces you to do. So when people say they find C4 really useful, they go, oh, the diagrams are great, but actually the power of C4 is the set of abstractions. It's that small set of abstractions with some precise definitions around what those different abstractions represent in the real world. And having teams have the discussion, so we have a thing here, is a container or a component, adds a lot more clarity and preciseness to the way that teams build and talk about and describe their software systems. I can illustrate this much more simply. I found some tooling early this week, which is it's kind of a clone of my structurized DSL tooling that allows you to define your architecture model with a textual DSL, but it doesn't limit you to software systems, containers, components. You can have any type of abstraction that you want to, because people want that freedom and that flexibility. They don't want to be constrained by C4. So here's an example from their docs. We're defining a service which consists of two components, backend 1 and backend 2, which themselves consist of more components. I'm confused. What's a component? Because now we're using that same word for two types of things. And that's the problem I was trying to solve in the first place with C4. We've reintroduced this what is a component problem because there's no defined thing here. There's multiple ways to interpret this. From a structurized DSL and therefore C4 perspective, perhaps they were trying to explain this. So maybe we had a software system called service, and that had two deployable things, backend 1 and backend 2. And inside these deployable things were components, the APIs and the GraphQL thing. That's one way to interpret that previous example. Another approach is to maybe say, well, we still have that software system, and maybe it's all deployable artifacts, but maybe we've just got some grouping. So maybe a combination of API 2 and GraphQL is logically seen as backend number 2 for some historical reason. And again, I like C4 because it gives me the ability to define stuff like this a bit more precisely. C4 is more suited to monolithic architectures and doesn't support distributed architectures well. This was written in a book, and I get a lot of questions about this, and it's not true. Again, first of all, we have to ask the question, what's a microservice? This is where we need James Lewis. Where are you, James? We need some hexagons. What is a microservice? I often hear people say, we're modeling microservices with C4, and we're modeling microservices as containers, and the API thing and the database schema as components inside that container. I'm like, no. Because it's your API and your database schema that are the deployable artifacts. Those are the containers. So what people have done is they've kind of dropped down one level in C4 too quickly. And again, it's about having a conversation. It's about being more precise. So here's an example diagram. In this example, I'm treating the combination of the API thing and the database thing as a single microservice. So in this case, it's a pair of C4 containers. Maybe a Spring Boot app talking to a MySQL database schema. So in terms of the C4 is not really suited to distributed architectures thing, imagine you have a microservices architecture. Here there are 8 services, pairs of containers, all color-coded. If you start adding more services, this diagram obviously gets more complicated. So how do you solve this problem? You have a bunch of options, and for those who came to my talk last year, you would have seen this before. This is one diagram showing all services. Maybe we draw one diagram per service. So my structurized DSL allows you to craft up a nice little expression and say, includes service 1 and things coming into and out of service 1. And it allows you to kind of slice and dice your model and draw a subset of the overall model. And then we can have a service 2 version with the same sort of syntax, and the service 3 version, et cetera, et cetera. So again, this is about creating a model of your software architecture and slicing it and dicing it in different ways. You could also use a different visualization format. So you could use something like a D3 force-directed graph. This is the thing I actually showed you last year, and I kind of moved things around, of course. And this is a much more concise visualization of the same data. It's still using C4 abstractions and C4 diagram types, but it's showing it in a much more condensed, concise way, which is kind of nice. And then you could load the whole thing into a tool like Ilograph. And you can see all of the information, and you start clicking around, and it zooms in and pans around and kind of focuses on the thing that you are interested in exploring and visualizing. So that's how I get to the C4 does support distributed architectures and bigger architectures. You just need to think about the way that you are visualizing that data set, essentially. People ask me, what are my thoughts on modeling n layers of abstraction rather than just 4? So the typical example I see is a software system is made up of containers. Containers contain modules, which contain components, which are made up of packages that contain code. For me, that's lots of levels of abstraction, and I don't think all of these levels are necessarily abstraction. I think a lot of this comes down to abstraction versus organization. And I think people get these two concepts a little bit confused. So imagine you're building a really boring web application, which is a bunch of components organized into layers. Maybe there's a web layer, a services layer, and a repository layer. So when we zoom in, we have a bunch of things like web controllers in our web layer, and then we have a bunch of services in our service layer. Traditional package by layer type architecture. People might want to draw this diagram where they say the two web controllers make up the web layer, and the two service things make up the service layer. And that's fine, because for me, this is an organizational construct. Those two web controller components sit in the web layer. The thing I probably don't want to draw is just the diagram showing a single box for web layer with a single arrow going to service layer. For me, that's not a useful architecture diagram. Why? Because for me, a layer is not an abstraction, it's just an organizational concept. There's no single interface or API into a layer. The API of a layer is really the combination and sum of all of the interfaces into the things that exist inside the layer. So this is a useful diagram to draw. I think removing the components is not necessarily a useful diagram to draw. And of course, you could do something similar. You could say that, well, the web controller components sit in this specific jar file. Again, it's an organizational construct. And that's absolutely fine to show on your architecture diagrams. Should we show dependencies to containers in an external system? This is quite a common question I get. And this question is generally asked by people who are a bit more experienced in C4, and they've started to promote or encourage or sometimes mandate C4 usage across all the teams in their organization. So imagine I am building a system called A, and you are building a system called B. I'm building a Spring Boot app, and I'm going to use some API that you are providing me to get data. When I draw my architecture diagram, this is how I'm going to draw it. I'm going to draw my container, my Spring Boot app, sitting inside my software system A boundary. My app, my container, has a dependency on your system. That's my architecture diagram. I don't care how you are servicing my API request. I don't care what technology sits behind that API request. It's none of my business. You can change it, and my diagram still remains the same. And for me, that's a good thing. From your perspective, imagine you are drawing your architecture diagram now. You might draw something like this. So imagine you are building a Node.js app. You are providing an API for other people to use or consume. And you know me, as System A, are using your API. From your perspective, that should be your architecture diagram. You know that you have an inbound dependency from me, but you don't know I have a Spring Boot app inside that system, and that's the thing that's calling your Node.js app. So we have two architecture diagrams that are showing the same thing from different angles. What people try to do is they'll take this one step further, and they'll say, well, what about drawing this as an alternative? So now we're showing both the Spring Boot app talking to the Node.js app inside two software system boundaries. And my answer is, please don't do that. Because essentially what you're doing here is we're showing that we know something about the internal implementation details of each other's work. Which means that when we change our work, when we change our code, those diagrams are volatile. The other way to look at this is it's actually a form of coupling. There's some detailed knowledge here that perhaps doesn't need to be known. And I might question why we need this knowledge. I see lots of organizations who have microservice architectures, and they want to draw diagrams like this. They want a single diagram showing all of the containers across all the teams collaborating. My kind of question that pops in my head is, are you really lots of teams, or are you really just one big team? So there's an interesting team boundary, Conway's law thing hiding in here somewhere, I think. There are some exceptions to this course. If you're doing good old-fashioned database integration, you might want to show that. And this is typically a historical thing. We don't generally do this anymore, but if you've got a bunch of applications inserting information into a shared database schema, then that's a good example of where you might want to show the container-to-container relationships, because it is a nasty implementation detail of a shared database. Some final things in the kind of how should we category. How should we model message-driven architectures? It's very tempting to draw message-driven architectures like that. So imagine you have a bunch of services pushing messages into Kafka and some services on the receiving end of those messages. This is factual, it's true, it's accurate, it's a traditional hub and spoke architecture. And that's essentially what most messaging systems look like. But this might be hiding the true story. Maybe the true story here is that microservice A is really only sending stuff to C via a dedicated Kafka topic called X, and the same is true between B and D. So here, what I'm doing is I'm modeling the Kafka topic as a C4 model container. And that for me makes sense, right? Because a C4 model container is an application or a data store. So I'm treating the topic as a data store. It's a bucket, and we can put messages into the bucket, and something's going to pull those messages out of the bucket. From a deployment perspective, we can put both of these topics onto a single Kafka bus on a single server, or we can federate them and have them across different servers doing forwarding and stuff, or they could be on completely different Kafka clusters. So again, we have a way to draw a deployment agnostic container diagram, which I think is quite nice. Arrows, you'll notice all the arrows go from the left to the right, sends messages to, sends messages to. One of the big questions I get about arrows is which way do you point your arrows? It doesn't really matter, choose a direction. Just make sure the text matches the direction. So I'm going to flick the right-hand side arrow the other way, 3, 2, 1. So now we've changed the direction, and we've changed the wording to subscribes to. So this is telling you the same story, just in a different way. And I think this is fine too, and some people might prefer this, and some people might prefer the other one, and that's fine, just pick which one you like the best. Some of the others in the audience might be thinking, well, I don't like either, because they're both cluttered, and having boxes labeled topic isn't really adding much value, and you might be right as well, so sure, why not? Here's a third approach, where now you link up and you show the point-to-point coupling, but on the arrow you say this is going via Kafka. And that's the nice thing about diagramming. There's often not a single way to do things. You have lots of different options, and you just choose the one you like best. What's the story you're trying to tell? Last one, I think. How should we model shared libraries? So imagine we are building a couple of apps, a couple of Java apps. Inside those apps are some components, and we have created a shared logging library that we are using from both those apps, like a jar file. This is how many people want to draw that diagram to show that the two apps use the shared library. And what they're doing here is they're representing the shared library, the jar file that we get out of our build process, and they're modeling that as a C4 container. That's misusing C4 because a C4 container is an individually deployable, runnable thing. And you can't run a logging library on its own. It needs to be part of an application. So this is not how I recommend doing it. What I recommend doing is you show the shared logging component inside the boundary of both apps, of both containers. And that's basically what you're doing, aren't you? You're taking a shared library and you're doing a copy, paste, deploy into both apps. I mean, you don't copy, paste, deploy. Your build process is doing this for you through dependencies and that sort of thing. But essentially, you've got two instances of that logging component running in two JVMs and two memory spaces. So that's why I would draw this diagram instead. If you want to then say that that logging component is shared, well, then you bring notation into the mix. So maybe have a different color, different type of gray, that you say the lighter gray represents a shared component from a shared library. Or again, you can do the organization thing. You could say that the logging component is sitting inside that shared library.jar file. So you have a bunch of different ways to kind of tell the same story, essentially. So that's my collection of mistakes, misuses, misconceptions. I don't really know how to end this talk. It's a bit of a weird one. So what's the kind of too long didn't read of all of this? Go read the website. There's lots of this stuff is actually answered on the website. There's a whole bunch of FAQs about things like microservices and lambdas. And there's quite a detailed section that actually defines the C4 level abstractions and diagram types. So many of the misconceptions and things I've been through are actually answers on the website. If the website is too much, then this is the slide you want to take a photo of. The C4 model is basically these 4 things. It's a set of hierarchical abstractions, it's a set of hierarchical diagram types, it's notation independent, i.e. not blue and gray, and it's tooling independent as well. And that, in a nutshell, is C4. So thank you very much.